examples to make sure that we are good to go. All right. Example 1. 2 over r equals 1 over 4r squared plus 6r minus 3 minus r over 2r squared plus 3r. Okay. So what do we have to think about as we get started? What do we have to think about as we get started? We have to think about our least common denominator. So here we just have the r. Let's factor this one to see what this denominator is. What do we need to do to factor that? Take out 2. Take out what else? R. 2r. So if we take out a 2r, what is left over? 2r plus 3. Okay. And then over here, when we factor the denominator, what do we get? Take out a GCF of r, and then we get 2r plus 3. Okay. Okay. So our least common denominator is going to be what? Definitely the 2r plus 3, parenthesis, because that's in these two. And then the 2r coefficient. So these ones have just an r, but that one has a 2r coefficient, which is a little bit more. So we need the 2r coefficient. Okay. Can you guys tell what the excluded values are? There's more than one of them. Yes. Well, it's going to come from this one. So what's the excluded value there? Not negative. It's 0. Yeah, anytime there's no plus or minus in between it, anytime it's just from a GCF, the excluded value is 0. And then the excluded value over here is actually a fraction. Can anyone tell? -3/2. So r cannot equal -3/2. Okay, so we have 2 excluded values for this problem. All right, now I tried to take down the video yesterday quickly enough. I have the video up from last year from my non-honors class. You guys, since you're honors, I thought that you could handle a different method for solving. And so I was consistent with having you guys do the same method that we learned yesterday. And I think that I took the video down quickly enough and then redid it. As you watch the video, if I had these nails, then that means you watched the right one. If I had pink nails, that means you watched the old one. Okay? So hopefully you saw me with blue nails. You guys are frowning like Miss Rice. I don't ever notice the color of your nails. So okay. All right, so you'll recognize it because you'll either be like, yes, this is what I watched last night, or you'll be confused just now. All right, so what we're going to do is we're going to take the entire equation and we're going to multiply the entire equation by what? 2r times 2r plus 3. We're multiplying the entire equation by this. Okay. So I have 2 over r times 2r plus 3. One over, and I'm going to always use the factored version because it's easier to see if it cancels out. 1 over 2r times 2r plus 3 times 2r plus 3 minus 3 minus r over r times 2r plus 3 times 2r plus 3. All right. So, actually, I'm going to give you guys some more time to write because it looks like some of you guys need it. Contacts today? You have your contacts today? Okay. I don't have any disposable masks, but the front office might. Yes. So we have two options. Oh, but has that been on your face already?
No.
Okay. Okay. Look at that. Look at that friendship right there. We appreciate. Keld, let it go. Or if you want to come back and slap Keld around a little bit, I will turn around for a moment so that I can't see it. All right. Did you just blow him a kiss instead?
I don't know.
Is there a lighter black side? Is there a side that looks like it's got some... Do
I don't think it's that. It's like a...
you want to go over and show him?
Yeah, but one of them is facing the right way.
What?
One is out backwards.
And then, Court, as you replace your mask, you can also whip out those headphones so you can hear me with empty ears. Marvelous. All right. So, what do we have that can cancel in that first term? The R's can cancel. And then we have a 2 times 2, which is what? 4. And this 4 is going to distribute. Okay, so 4 times 2R is 8R. And then 4 times 3 is 12. So we have 8R plus 12. All right. Yeah, so it's not showing up in our answer because it's part of what we multiplied. Yeah. All right, so then when we look at our second term, what happens with the 2R times R plus 3 and the divide by 2R times R plus 3? What happens? They completely cancel. Completely cancel, completely cancel. And we are left with the 1. All right, over here, we have an R and a 2R plus 3. And what happens with that and what happens up here? Everything cancels except for the 2. So what I'm going to do is I'm going to keep my negative sign, and since that negative sign needs to distribute, but a 2 also needs to distribute, I am not going to complicate things by trying to do both at once. I'm going to leave my negative, and I'm going to know that it needs to distribute, so I'm going to put parentheses. And all I'm going to do is I'm going to do 2 times 3 and 2 times negative R. So 2 times 3 is what? And 2 times negative R is what? Negative 2R. So I'm always going to be careful to watch out for negative signs because I would think that this would probably be the easiest place to miss distributing a negative. And when we don't distribute a negative, we kill baby foxes, right, James? Right, Keld? That's where we kill baby fox. We don't want to do that. They're so cute when they're babies. All right. So we got that. So now what should I do to keep solving this problem? You guys are so whispery at that table, and it's making me want to high five you in the face with a chair.
It smells really bad.
Kel did clean his jacket with a bleach wipe a little bit ago. Yeah. 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 My favorite is you guys like holding your noses, but you do have a face mask on, so just like move it up and like pinch the nose strip. Yeah. Okay. Now we've gotten our feelings out. It smells. Okay. So now can we stop whispering now that we've gotten our feelings out? Okay. 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 So now everybody knows. Okay. Okay. Let's move on. All right. So everybody knows. Get it? Knows. Everybody knows. Okay. All right. Wah wah. Not a greatest common factor yet, because we're actually just solving a regular equation. So we're not even really doing math 3 stuff anymore. But we do need to get rid of these parentheses. How do we do it? Distribute, yep. So 8r plus 12 equals 1. And then what do I have? Minus 6 plus 2r. And what do I get? Yeah, positive 2r and a negative 7. Oh, negative 5. Woo! Woo! It was a typo. It was a typo. I wanted to make sure everybody was awake. All right, now what do I do?
The thing.
Emma, what do you want me to do? Minus 2r to the other side. Subtract the 12. And then what do? We get r equals negative 17/6. Okay. And before you decide, yes, that's a great answer, you just go back and you compare it with your excluded values and you make sure that it is not them. So one of our excluded values was 0. Is negative 17/6 the same thing as 0? Well, Jack, we have bigger problems then if we think those are the same. That was me pushing up my glasses. Okay, is negative 17/6? He maintained that. We made eye contact. I stared him down. And he did not flinch. He was like, I maintain that negative 17/6 is in fact 0. Is negative 17/6 the same as negative 3/2? No. All right, so that means this is a good answer. We're going to keep it. R equals negative 17/6. We like that conclusion. All right, we are done with this problem. Let's move on to the next one. How did we feel about that process of multiplying by the least common denominator and using it to get rid of our denominators so that we just had a math 1 level equation to solve? Can we handle that? Okay, so similar process to yesterday, but instead of using the least common denominator to get rid of the denominators of 3 fractions, so we only have 1 fraction, we use the least common denominator to get rid of the denominators of 3 fractions, so we only had 1 equation. So same idea as yesterday. All the whispering is making me want to high-five several of my students with a chair. In the face. In the chair, in the face with a chair? Did I say in the chair with a face? I mean, it's okay, outside of the box thinking. It could happen. All right, next example before we get started with the assignment. All right, here's the next one. 1 over 3x to the third equals 1 over 3x minus x plus 1 over x squared. That's it. That's the whole problem. It looks so simple, doesn't it?
Said that now I know it's not gonna be.
All right, between the three denominators, what is the least common denominator? 3x cubed. So we're going to say LCD is 3x cubed. Okay. And then what is the excluded value that we're going to make sure we don't have? 0. X cannot equal 0. All right. So when we get done with the problem, we're just going to make sure that is not our final answer. Okay. I'm going to take the entire equation and I'm going to multiply it by what? 3x cubed. So I'm putting parentheses around the whole thing, multiplying it by 3x cubed. Okay. So now I'm going to write out every single term in the equation. I'm going to multiply it by 3x cubed, multiply by 3x cubed, multiply it by 3x cubed. Now, I've been choosing a lot of equations that just have 3 terms in them, but technically somebody could write an equation where there's like 17 different things. And that would be fair, but it would be evil. So, you know me, I'm not evil. I just give you 57 problems every day. So I did not do any questions like that.
I recognize it.
Yeah. A little bit. I'm not in denial, you guys. I just find all the math problems and I'm like, oh, that's such a good one. I got to assign that one too. Not at all. I do appreciate you defending me, though. That was very nice. Yeah. Hannah, you get an A. Keld, I shall think of you later when I cry to my therapist. All right. So with the first one, what happens? They completely cancel. 3x squared and 3x squared, they completely cancel. What do they leave behind? A 1. All right. With the second one, they do not completely cancel. What gets left behind? An x squared. So the 3's cancel and one of the x's cancels, but it leaves an x squared behind and you get 1 times x squared. So x squared gets left behind. All right. And then what about for the last piece? What happens there? What cancels? X squared cancels. And then what do we need to do? Take the x plus 1 times the 3x. So we get 3x squared plus 3x. And then what should I do with this? Okay, put a negative in front of it. And is it right if I write it like this? Is that correct? No. So we're subtracting this, but we're subtracting both of those, right? So I need to put that in parentheses, and I need to distribute that negative. Yes. So this, because it was x squared, right down here, the 3 here, 2 of them canceled out and left a 1 behind. Yeah, you got rid of 1x, and it left 2 behind, and then it was x squared times 1. All right, so now what should I do? Now, distribute the negative, okay. And then what should I do? Combine like terms. Held, stop coloring and look up here. I can see you. You're very close. All right. And now what should I do? I can subtract over the 1, but do we like for our x squared term to be negative? We're not really a fan of it being negative, so what should I actually do? Yeah, I'd probably move it over to the other side, actually. Yeah. When you do slide divide, you should not have a negative in front of the x squared. So I'm going to make my x squared term positive by moving it to the right side. So what method are we using for solving this? This is a slide divide problem. How do we recognize it as a slide divide? There's no GCF, and it's got a number in front of the x squared. Okay. So we are looking for two numbers that multiply to 2, 2 times 1, two numbers that multiply to 2 that add to 3.
Two and one.
2 and 1. So we got x plus 2x plus 1. Are we done with that? No. What do we have to do?
You slid by.
Divide by what you slid by.
And you get 2x plus 1, and then you get 2x, or then you get x plus 1.
Okay. Is the boosh part of it, or is that?
Yes, it's a part of it. I need to write it. B-W-O-O-S-H. Boosh. You have the W.
You said W-O. Double O. W-O. You said okay.
W and then O-O.
Wouldn't that be whoosh?
Yeah, that'd be like boosh. Like, yeah.
All right, so what are our answers? Yeah, you're right. Negative 1/2. Okay, now if we look back at our excluded value, are these answers okay? Marvelous. Are you done? It does not mean you did it wrong. Hey guys, this was a great question. What happens if you get your excluded value as an answer? You just put an x through that. So if we had gotten x equals 0 and x equals negative 1/2, we would have crossed out the x equals 0 and we would have said, just kidding, that's not an answer. And we would have only put a box around x equals negative 1/2. It doesn't mean you did it wrong. It means that one of the two answers was an extraneous solution, which is an extra solution that's not valid. It's one that you mathematically solve for, but it doesn't work. Yeah, and it's possible. Hey guys, this doesn't happen very often, but it is possible that you could only get one answer and it ends up being the excluded value and the problem is not solvable. It is possible to happen, but as a math teacher, if you said, Miss Rice, find one that does that, it would be very hard for me to find one that actually does that, because think about like all the numbers we have in the world. Finding one where the excluded value matches up with the actual answer would be very difficult for me to do. Infinity.
What comes after like 100 billion?
100 billion and 1.
Oh, what comes after 999 billion?
999 billion and 1.
Oh, okay. After billion. Or trillion?
A billion and 1.
After a billion?
A billion and 1.
And then billion and 2?
A billion and 3. This is fun. Ask me another one.
Wait, what happens like, is a billion one? Is that like trillion? Or is that a whole different thing?
Okay, we're gonna do a little decimal place activity, Keld. Here's the fun. Okay, ready? All right, here's your like ones place, tens, hundreds, right? Thousands, 10,000s, 100,000s. Here's your millions, 10 millions, 100 millions. There's your billions. There's your 10 billions, 100 billions. There's your trillions. No, there is. So when you said if this is 1 billion, what's bigger than 1 billion? It is 1 billion and 1.
I said, what is after 999 billion?
999 billion and 1. I could just add 1 to anything. No. Anything that's bigger than a billion, you add 1 to it and it's bigger. You don't have to add a whole billion to it. You keep adding 1.
I gotta go.